Sometimes you'll be asked to determine if something is a function simply by its graph. We've talked about the vertical line test, and we've stated that you draw a vertical line all over the function, and as long as that vertical line hits your function only one time, then you know, or your graph one time, you know that it is a function. Now, from once we know that we're dealing with a function, we may want to identify the domain and the range, meaning we want to know what x values are covered for this graph and what range values or y values are covered for this graph. Now, we know that domain represents our x values, and x values occur along the x-axis, which go in a direction from left to right. And then we have our range values, which we know are our y values, and that covers our y-axis, which we know that goes down to up. Okay? So why am I doing that? Well, when I look at a function, I want to identify, are the ends of that function going left or are they going right? Or is there a specific value that it stops at? Or is it going down, or is it going up, or is there a specific value it stops at? Now, let me preface by saying, when you see a graph written like this and it's going off the screen like this, these are arrows, meaning the graph actually continues. Okay? So, when I look at this graph in reference to domain, and I look at this arrow over here, I notice that this arrow is headed to the left. Now, you may say, wait, but it's going down. Yes, it is. But I'm thinking in reference to left to right only. And this graph is going to keep going to the left, gradually, keep headed to the left side, getting wider and wider and wider. And when I look at this other arrow on the other side, it's headed to the right. And again, you might say, but that looks like it's going up. Yes, but in respect to domain, we're thinking left to right only. Now, when I look at the arrow going down or up, I can say, okay, it's going down, and I can say this one's going up. And there are no holes. The graph is perfectly continuous in the middle, so there's no issues. So that means every input between these values will have an output, so we're doing good. So now I can identify what my domain is. So I'm going to look at my pink descriptions, which are left and right. And whenever I have those type of descriptions, that just means I'm headed to negative infinity to positive infinity. And keep in mind, you are using interval notation. And now I'm going to look at my blue descriptions, which are down and up, and that is negative infinity to positive infinity. So that means all the values are included within this function. All right, so we're going to do the same thing we did a second ago with this graph. It's going to look a little different, right? Because you'll notice I have the graph, an arrow on one side. It's a terrible looking arrow. Let's draw that a little different. Sorry, this is an ugly arrow. I have an arrow headed in one direction, but I actually have a starting point on the other side. So this is a little different. I don't have an arrow. So where that point is, I'm going to identify its x value because domain cares about x values, and that is 0. And then this arrow in respect to domain is headed to the right. Now I'm going to think about in respect to up and down. So this point, its y value is actually 0, and this arrow is headed up. So now, to identify my domain, I'm looking at my x values. So the smallest x value that I have is 0. It is a point that is included, so I use a bracket. And then I'm headed to the right, which is infinity. And when I look at the smallest y value I have, it is 0 included. And I'm headed up, which is also positive infinity. Now, it is by coincidence that our domain and range in both of the problems we've done so far are the same thing. That does not always happen, so make sure you don't expect to see that all the time.
Okay, so you may look at this one and think it's going to be very similar, and it is, but it's just going to be slightly different. So again, we have a starting point here, and then we have an arrow extending in the other direction. If I look at my x value, this is 0, and this arrow is headed to the right. And then when I think about in respect to my y values, the y value is 0, but this time it is headed down. So you'll notice the domain is going to be very similar. 0 is included, and I'm headed to the right. However, my range is going to be a little different this time because I'm headed down up until 0, and down is the smaller value. So I'm going to put negative infinity first and then 0, just like that. Okay? Right, looking at this next one again, I encourage you to pause this video and then resume to find the answer. All right, so on this graph, we understand that these are arrows on both sides. This one is headed to the left as well as up. This arrow is headed to the right as well as up. So for domain, I'm thinking about my left to right, so that's pretty easy, negative infinity to infinity. But when I think about range, I'm thinking about my up to down, and I have up and up, and I can't have infinity to infinity. I got to have, so to speak, a starting point. So I think about what is the lowest point this graph hits, and when I think about this point right here that represents 0, 0, there are no y values that go below that value 0. So that actually ends up being my low point, 0, all the way to infinity. Looking at this next one here, I have a coordinate point that is at -3, -2. And then everything is included, and I continue going off until I get to this arrow, and this arrow is headed to the right, and it is headed up. So when I go to identify my domain, I'm looking at my x values. Oh, excuse me, sorry, my allergies are bothering me. -3 is an open circle, meaning that it is not included, so I'm going to use a parentheses and a parentheses on the other side. And for my range, my lowest value is -2, and I am headed up. Okay? As always, I hope you found this video helpful. If you have any questions or concerns, please don't hesitate to reach out.